work on step three. Step three is where we take all the information we just got in step two. The goal that we just got in step two was that the X bars are going to follow a T distribution with degrees of freedom 11. So I'm going to come over here to step three. And this is kind of a big action step. It's our do step. So we're going to find the p-value using the distribution from step two. And like I said, we know that the distribution is going to be a T distribution, which looks an awful lot like a normal distribution. It has a slightly different formula. So it's going to have degrees of freedom 11. In the middle, though, our T distribution on that is always standardized. So we're going to have a mean of 0. That mean of 0 is going to represent our 355 milliliters. And then on the other side here, got -1, and that same distance will give me -2. And I have a feeling we're going to be over here. And so now I've got to remember my formula for my test statistic. My test statistic, again, just the standardization of my X bar, if mu is my, the mu in the null hypothesis is my population mean. So there's my formula for test statistic, and my X bar was 352.9 milliliters. My population mean is assumed to be 355. And then again, that standard error I got back here of 0.63 milliliters. So 0.63. And when I work those calculations out, I should get -3.33, which puts me way on the left over here. There's -3.33. And again, remembering this is a left-tailed test. So that means my p-value is going to be the area to the left. It's really, really small. Really, really small area there. And in order to find the precise area, I am going to need to go to StatCrunch. So let's jump over to StatCrunch. And I'm in StatCrunch now. And what I want to do is go to, let me get rid of this keyboard. This keyboard's in my way, not happy. Oh, I need to go back. Going back to StatCrunch. Okay, I open up StatCrunch, and if I make this a little bigger, I'm going to go over here. Anytime we need calculations, we're going to go to Stat Calculator, and we are using the T distribution. So I'm going to jump to the T distribution here. I need to change my degrees of freedom. I need to change my degrees of freedom to 11. So I'm going to change that to 11. Oops. 10 there. 11. And then I'm going to change, it's already left-tailed, so that's good for me. And then I'm just going to change this value to -3.33. And then when I click compute, this drawing should look an awful lot like my drawing, and it does. Notice how far out in the tail we are, and that probability of 0.0034, oops, I need to do that. Doesn't matter, I've got my value. That makes sense to be a really, really small p-value. So I just got that this p-value is equal to 0.0034. So that p-value is telling me that if it's true that our mean really is 355 milliliters, the chance of us getting a sample mean of 352.9 milliliters in 12 cans, the chance of that happening purely by luck or by chance is 0.0034. So that's a really small chance of getting our data if that null is true. And then in step 4, we will conclude and then interpret our results.